A spherical steel ball bearing of diameter 1.4 cm is placed on a wooden block of mass 50 gram, such that the block and the ball bearing are floating in a cylinder of oil as shown in figure 1. In the following parts of the question, you may assume that the density of steel is 7.85 gram per cm cube. The density of oil is 0.83 gram per cm cube. Question. Consider the ball bearing and the wooden block as a single system. Draw labeled arrows to indicate the external forces acting on this system. So the external forces are the weight. It's a combined weight of the ball bearing and wooden block, and upthrust. Question. Determine the upthrust acting on the system. The upthrust is equal to the weight of the block plus weight of the ball bearing. So the weight is given by mg, and m is given by density times volume. So substituting value, this is what we have, and the upthrust is 0.61 Newton. Question. Hence, calculate the volume of oil displaced by the wooden block to keep the system afloat. By principle of flotation, the weight of oil displaced equal to the upthrust. So rho Vg equal to 0.601. Rho is the density of the oil. So therefore the volume is given by the upthrust divided by density times G. So we have V equal to 73.8 centimeter cube. Question. The ball bearing now rolls off the piece of wooden block and falls into the oil. Explain how the oil level in the cylinder will change. Now the upthrust was the weight of the block and the ball bearing when the ball bearing was on the block. So when the ball bearing rolls off, the upthrust become mg, the weight of the block. The weight of oil displaced decreases, and the oil level will drop by a volume equal to the mass, by the volume of oil equals to the mass of the ball bearing itself. So V decrease will be equal to the mass of ball bearing divided by the density of the oil. When the ball bearing enters the oil level rises by the volume of the ball bearing. So the V increase will be equal to mass of the ball bearing divided by density of the ball bearing. Since the density of the ball bearing is larger than the density of oil, the oil level will decrease by the amount V decrease minus V increase.